Alright, so last thing today, we're just going to do a quick review of phase changes. So remember, the three phases, solid, liquid, and gas, you need to know how all of the particles in each of those phases behave. Alright, so if we look here, the first phase change, melting. Okay, so just think of melting an ice cube. You're going from solid, an ice that's solid, to liquid, for example, water. So when we're going from solid to liquid, think about, are we gaining or losing energy? If we look at these two sets of particles going from a solid here to a liquid, the solid particles are a lot lower energy. They're not moving around nearly as freely or with as much kinetic energy as these liquid particles are. Alright, so think of it, the higher the phase, the higher the temperature phase we have, the higher the energy is going to be. So when we go from solid to liquid in the melting process, we're gaining energy because we're going from lower energy solid particles to the higher energy liquid particles here. Okay, the opposite of melting is freezing. So with freezing, we're going from liquid to solid down this way. So when we're making this transition, we're going from liquid particles that are moving around with higher energy and more freely to solid particles that are moving around with lower kinetic energy. Alright, so these molecules in the freezing process, they are losing energy because we're going again from higher energy to lower energy. Alright, so freezing and melting are opposites of each other. The next set of phase changes, evaporation. So evaporation, we're going from liquid, for example, evaporation, another word for it is boiling, right? So think of boiling water, right? We're going from liquid water to steam, which is, part still water droplets, but mostly water vapor. So when we're going from liquid to gas, which is what we're doing in the evaporation or boiling process, you can think about all these particles that are moving really quickly in the gas phase. They have a lot of energy. These are really high energy particles. They're just flying all over the place here. This is going to be a lot higher energy. So when we're doing the boiling or evaporation process, we're going to gain energy as we go from liquid to gas. And then the opposite of evaporation would be condensation. So condensation, instead of going from liquid to gas, is going from gas to liquid. So in condensation, we're taking these high energy gas particles and cooling them down into the liquid phase. So this is going to be a loss of energy. So think about this again. In evaporation, we went from liquid to gas and gained a bunch of energy to get these high energy gas particles. And this time with condensation, we're basically doing the opposite. So now we're taking these high energy gas particles and lowering their energy, cooling them down into the liquid phase, so they're going to end up with a lot lower energy. Alright, and the last set of phase changes here, sublimation. So remember, this is one that we may not have heard of before this year. This is going straight from solid to gas. Alright, so when we're going from solid to gas, the same idea here. We're ending up with these really high energy gas particles, so we're going to end up gaining energy in this process. So again, sublimation here, we're just skipping the liquid phase and going straight from solid to gas. Alright, and in this process, we will have gained energy. So sublimation, straight from solid to gas. And then the last phase change here, the opposite of sublimation, would be deposition. Okay, so in deposition, we're going straight from gas to solid, and again, skipping the liquid phase. So you can imagine here, this is a big loss of energy because we have these high energy gas particles, and we end up with these much lower energy solid particles. Alright, so you need to know all 6 of these phase changes for your final exam. So please look back through your notes and know all 6 of them. Alright, thanks for watching. I'll see you in the next video.